So today we're going to start dissecting a fish. Now, in any dissection, the first thing that you do is observe the external features. So we're going to look at some of the external features of this fish. I believe it's a croaker. It's a croaker. Yeah, croaker, which is a fairly common marine fish caught in the Gulf of Paria by commercial fisheries. Okay. So the first thing I'd like for you to observe is the way the light shines on the scales of this fish, right? You see that the top of the fish is darker than the underside of the fish. This is a type of cryptic coloration that is known as counter shading. So in counter shading, a predator from above looking at the fish is going to see a dark object against a dark background, right? So that's why the top is darker. A predator from below is going to see a light object against a light background. So the fish is going to be invisible to predators from both below and above. So counter shading is one very neat little phenomenon that you could observe very easily on a fish. Now, the other thing I'd like for you to note is this line running alongside the fish, right, on the lateral portion of the fish. Okay, so that is called the lateral line, and this is a sensory structure. So within the specialized scales of this structure, you have special sensory organs that are picking up on vibrations in the water. Now, we need to be able to identify our fins. So you have your pectoral fin. The pectoral fin is for steering, right? One on either side. You have your pelvic fin, right? The pelvic fin is usually used for braking or for going close onto the substrate, right? This is the anal fin, which is close to the anus of the fish. You have your dorsal fin, okay? And you have your caudal fin or your tail, okay? Right. Now, when we look at the respiratory structures of the fish, the first thing we look at, so we're looking at the fish face on, right? You have your eyes, you have these little nostril-like structures, right? These nostril-like structures are not for breathing. These nostril-like structures are for picking up on chemicals in the water. When we talk about respiration in fish, we think about their gills and what happens when they open their mouths. Okay? So opening the mouth of this fish, you can see, or you should be able to see, things like that happen, straight past the tongue over the gills of the fish, right? So the respiratory system of this fish is isolated to the mouth and here where we have the operculum. Now let's open up these opercula. If you look behind the operculum, you're going to see the gills of the fish. So what happens? Water flows into the mouth and over the gills, exiting the operculum of the fish. Okay? Now, to dissect out a gill, I will need a pair of scissors. And my trusty forceps. So this, of course, is something that you can do at home when you're cleaning your fish for your Saturday fish broth, right, or your weekend or your weekday fried fish, dal and rice and fried fish, you can do a quick dissection of the gill to observe these structures. Now, those of you who buy your fish in the market, you know that looking at the gills is one of the first things you do to tell if your fish is fresh and deserving of your pot, or if it's not fresh at all. Okay, so if the gills are looking gray, then your fish is not good. If they're nice and red, then they're close to fresh. Now, if you were to look at this, what you're seeing is a clump of tissue held together, just stuck together, right? So these are your gills, and this piece of bone here that holds the gills in place is the gill arch. And then you have, on the opposite side of the gill rakers. So these gill rakers are to protect the delicate tissue of the gills from damage, because remember, this fish is basically taking water in through its mouth, and that water, which could contain a manner of all debris, is going to wash over their gills. So the gill rakers are protecting the delicate filaments of the gills, right? And water, fresh water washing over these gills is going to provide oxygen to the deoxygenated blood that is flowing in this gill. Now, this doesn't look like anything very special until you put some water on it. So what you're seeing here is a big old clump of tissue all mashed up together, and then we pour some water on this. And I'm hoping that the difference is very much visible. But you're starting to see the filaments are separating out, okay? And you could actually see them as individual filaments when it's submerged in water. This allows for having a large surface area to volume ratio, which is going to allow for maximum absorption of oxygen from the water that's coming in via the mouth of the fish, right? And maximum removal of carbon dioxide following the opposite route, okay? Now, in the fish, in a fish gill, you have something called a countercurrent exchange. So the gill is set up in this orientation in the fish, right? And water flows in this direction, right? So water is flowing in this direction, so we want to have the blood flowing in the opposite direction. And this allows fresh water to always meet blood that's always slightly less oxygenated. Okay, so we have this countercurrent exchange that allows for maximum absorption of water, of oxygen, and maximum removal of carbon dioxide. Okay, now when you're drawing this structure, you would want to have a representative of the shape. You'd want to label your gill filaments, your gill rakers, your gill arch, right? And you'd want to get as close as possible to talk about any little things that you see. Now, if you are dissecting this out, you may also want to, let's move this back here. And as you can see, I have a hole in my glove, but that doesn't matter because it's just a fish. You can actually cut off the entire operculum to display okay. So first off, let me demonstrate how much this thing can open. Okay, all of this can expand for this fish to make the largest volume possible to take in a huge amount of water and then compress to pass the water over the gills, right? So you could cut open this operculum to display the gills. The scissors do not appear to be equal to the task. Let me get a sharp up here. Or do it one layer at a time. Now, if you're doing this with kitchen tools, you need to be very, very careful, okay? I don't want anybody cutting their fingers, getting themselves hurt, and then your parents want to come after your biology teacher. Okay. So, this is our respiratory system, and very closely associated with the respiratory system, just behind this layer here, you will have your circulatory system. You'll have the heart right behind the gill. Okay, so we want to talk about the fish for BIOL 281, animal diversity from an evolutionary perspective. Okay, so the first thing we look at when we're looking at any organism for dissection is the external features. So this guy looks a little bit damaged because I just butchered his gill out for another class, but we're going to just make some observations on his body. Right, so this is a crow, which is a commonly caught commercial fish species in the Gulf of Paria. And the first thing we want to look at is his coloration. So he's fairly fresh. He was caught earlier this week, I believe. Yeah. So he's in fairly good condition. All right. So the first thing to note is that his upper side is darker than his lower side. All right. This is a phenomenon known as countershading. So countershading is a type of cryptic coloration that allows aquatic species to remain hidden from predators, from pelagic or free-swimming predators, either above or below. A predator from above, like say a pelican or a larger fish swimming from above, would see a dark object against the dark substrate of the ocean. A predator from below, like say another shark, forgive that piece of a glove there, a shark or another large fish, would see a light object against the sky or a light background. So this fish is effectively hidden from above and from below by virtue of its coloration. Okay, so let's note some sensory structures. You have your lateral line. Okay, you can see the lateral line is this different type of scale running along the side of the fish, and that lateral line is a sensory structure that picks up on vibrations. Okay, now when we're thinking about the evolutionary perspective of fish, we are also looking at their girdles, right? So this here, these are the pectoral fins. These pectoral fins are analogous to your shoulders, or homologous actually to your shoulders, right? So this pectoral girdle on the fish in terrestrial animals became the shoulders. And right below we have the pelvic girdle, and these pelvic fins are homologous to your hips and legs, right? So in terrestrial vertebrates, this pelvic girdle became the lower limbs. Okay? And on fish as well, we also have the dorsal fin, the caudal fin or the tail, and here we have the anal fin, which is close to the anus of the fish. Now, the bulk of support in this fish happens because of the body, of the fact that it's aquatic. It's floating around in water, and water is providing a great deal of support for the body of this fish. So all it has to do is to leverage itself through the water. It doesn't use its fins to move it forward. So it doesn't swim by flapping its fins. Its fins are mainly for steerage, right? For steering. The fish obtains thrust and forward movement by waving its tail, basically, waving the tail end, right? So the pelvic and pectoral fins help to keep the fish from rolling in the water column, as does the dorsal fin, right? So it keeps the fish upright while the tail and the back end of the fish obtain thrust to move the fish forward. Okay, so how does this guy breathe? So let's open up the mouth. You can see the mouth is very expandable, so it could take in large bulks of food, right? Large pieces of food material. And if we look directly into the mouth, you're seeing the tongue. Okay, so I always look at the tongue of snappers and croakers because I'm always hopeful that I'm going to get, you all know my favorite parasite, the Cymothoa exigua, which is the little isopod that takes over the tongue of a fish. And it basically becomes the tongue of the fish. So I'm always excited, hoping that I get to see one, but nope, it's a normal tongue. Healthy tongue. Okay, so the mouth is very expandable. Okay, so this fish could take in food that's larger than the actual size of the mouth that you would see when it's not expanded, right? Now, let's remember a little bit about where the vertebrates are in comparison to other organisms. So vertebrates are chordates, right? Chordata is a phylum that contains 3 major groups, 2 of which are invertebrate. The cephalochordates, or the lancelets, and the urochordates, or the tunicates, of slow-moving, filter-feeding organisms. The urochordates, in their adult form, are sessile animals known as tunicates. The lancelets are very sessile. Those are the cephalochordates. They're fairly sessile, slow-swimming filter feeders that bury themselves in the sand. When we start talking about the vertebrates now, we start talking about species that move very quickly. And this ability to move is what has driven vertebrate design. Everything about the design of this fish is geared towards its ability to move quickly enough to find food and move quickly enough to evade predators. Firstly, the scales. The scales are overlapping and they form a very smooth surface for the fish moving forward. As the fish is moving forward, this mucus-covered body surface is not going to be met with much resistance going through the body of the water column. The streamlined shape also allows the fish to cut through the water with very little resistance. Now, one of the advances that we see in the fish, in the chordates, in the vertebrates, compared to the earlier chordates, is the separation of the respiratory and digestive systems, right? Now, if you remember filter feeders, they take in a huge amount of water. That water goes over their gills. They have filtration happening at the gills, and whatever is filtered out is digested. But these guys now have isolated their respiratory system to the front part of their body, and they have ensured that their respiratory system does not mix at all with their digestive system. So they could spend a lot of time digesting their food and taking out all of the resources that they need from their food as slowly and as carefully as they need to, while maximizing rapid uptake of oxygen to fuel locomotion via their respiratory system. And this is a major advance that we see that allowed for greater speed and greater agility in the vertebrates, and this has driven their design. As you move from the fish going up to the mammals, you start to see much more efficiency in respiration, particularly when you come out into the terrestrial environment. So one of the things to note is that we have our separation of the respiratory and digestive systems. So if you were to open up the operculum, so this is the operculum of the fish, right? You were to open up the operculum, you would see the gills in place. So our gills, ouch, I've already removed the first gill, which we'll look at in a second. So you have your gills. The gills are held on pieces of bone and cartilage called gill arch. You have gill rakers, which are preventing large objects from hitting the surface, the delicate surface of the gills. And then you have the actual gill filaments. Now, when you take the fish out onto land, it's not going to efficiently acquire the gases that it needs because these gills are going to clump together. They're no longer supported by water, so they're just going to clump together and stick in a big old mass. But if you were to extract a gill and suspend it in water, you will see the filaments beautifully separate out, which is giving us an idea of one of the key characteristics of a respiratory surface, which is having a large surface area to volume ratio. Another key characteristic that we're seeing is the red color, right? This red color that we're seeing is due to the heavy vascularization of this gill. This vascularization means that there is a very ready blood supply taking deoxygenated blood to the gill and removing oxygenated blood, carrying it to the rest of the body. Okay, so what we're going to do now is to cut open the body cavity of this fish. So the first thing you do is insert the tip of your scissors into the anus of the fish. Now always keep the tip of your scissors pointing upwards and outwards. If you go juk, 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 what you're going to do is just damage the organs on the inside. So you want to be very gentle, very delicate. Okay, now you could use a scalpel for this, but the scalpels, I find I don't have enough control with a scalpel. Okay, that's because my life work is not dissections, so I don't have enough opportunity to develop the technique of using a scalpel efficiently, very efficiently. So it's easier for me to control the scissors, so that's what I use. Okay. So I'm seeing I'm cutting through the layers. Okay. I'm going to take a scalpel here. After all of that talk about a scalpel, I'm taking a scalpel here because we have some flesh that is a little too thick for me to get at with the scissors. I probably need a bigger scissors for this size of fish. Okay. So this is something that you can actually do at home. You can go buy yourself a fish in the fish market, and you can cut it open to make observations on the insides. Get back to scissors here. Now, one thing that often surprises me, even though I'm aware of it, is how little of the fish is actually internal organs. Most of this fish is made up of muscles for propelling it through water. Okay. Literally just the belly of the fish contains the important organs that allow this organism to complete all of its life functions. Okay. So we're tearing through some muscle, some mesenteries. Remember, the mesenteries are bits of tissue that hold the organs in place. Thank you. Okay. So this large white structure you're seeing here, I can immediately tell you that's a swim bladder, right? The swim bladder is an adaptation that bony fish have that help them to float, to stay afloat even if they're not actively swimming, right? And when you look at the dissection of the shark, you would see that sharks don't have a swim bladder, which is why sharks have to constantly be swimming, constantly be moving. Now you can see why this fish is desirable to people who eat fish, because it's nice and meaty. Forceps. Okay. So let's tease out the swim bladder here a little. Okay. So this is the swim bladder, again, which helps with flotation. I am making such a mess of all of these lovely pieces of equipment. I'm going to have to stay back and help clean up just out of guilt. You're probably guessing I'm the type of cook who dirties every single piece of wares in the kitchen when I'm cooking. You wouldn't be far off. Which is why I'm very happy to have a very symbiotic relationship with my sister. I dirty all the wares and do all the cooking, and she does all of the cleaning up. Okay. So this here, if you remember, this is the pelvic girdle, and this is this girdle is joined together here, so it's going to take a bit of elbow grease to cut through. There we go. Right. So this fish was frozen and thawed, so we have a little bit of tissue damage going on, which is to be expected. But let's see what I can identify here. All right. Now, one of the things about dissections is that you want to keep things wet, right? That helps to float, well, clear all the blood and float all of the organs apart. So here we have our gills, right? Our gills, and behind the gills we have the heart, okay? Now, if you remember, in the heart of a fish, you have a unidirectional flow of blood, right? So it's a single chamber heart. It's not like what you would see in the amphibians and reptiles, which mainly have 3 chambers to their hearts, and the birds and mammals that have 4 chambers to their hearts. Okay, so we have our lovely swim bladder. This stripe here, this creamy stripe that we're seeing, if we poked around, we would see the twin of it on the other side, right? Right here, you're seeing the pair. It comes in pairs. This is the reproductive, the gonad of the fish. Now, I suspect because of the size and because this is a white creamy structure, right? And you're not seeing like distinct eggs patterned into it, like little blobs of yellow, which would signify eggs. This is most likely a male. However, I cannot, as a scientist, I cannot definitely tell you that this is a male. What I can say is that it's either a male or a sexually immature female, right? Because you're not seeing developed eggs. So these are the gonads, and as you can see, the gonads again open to the cloaca of the fish, right, where you have the reproductive, digestive, and the osmoregulatory sections of the fish opening out into a single opening, right? So again, the swim bladder is for flotation. This here is the digestive system. So this is the gut. And if we were to move this further up here, you will see the stomach. The stomach contains some gunk of digestive food, right? There's little way for us to tell what is in here because it would have been broken down by the digestive processes of the fish, right? So this is the stomach again, the J-shaped stomach leading to the intestine. And I'm not seeing any CK. I believe this is because this is a carnivorous fish. If I were to move this up a little, again, I'm creating a big old mess here to clean up after. Okay. The liver appears to have either been damaged or it is hiding beneath and behind the swim bladder. All right, so again, gonads, these little stripes here. I'm going to try to pull the swim bladder out. Okay. Right, so teasing the swim bladder out. Forceps. Okay. So one of the reasons why I actually developed an interest in biology is because of my mom. Whenever she was cleaning fish, so okay, so this is like some fat bodies on the swim bladder. Whenever she was cleaning fish or chicken, right, the swim bladder just got deflated. I would be at her elbow helping, you know, as little kids do. Another word for being annoying. Okay, so I'm actually not seeing liver. Oh, no, 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 no. Liver is up here. So here we have this tissue here. It's not very easy to see. This right here, heart, liver, right? Yes. So back to my little story. I would be helping my mom out, handing her things so she could keep her hands clean. So I would hand her the salt, or hand her the flour, or hand her the seasoning, and she would identify the parts of the fish for me. So I was a 7-year-old who could identify everything in a fish or a chicken. I knew what the crop was for, what the gizzard was for. And that's basically how I spent my early life, helping my mom out in the kitchen and learning all about the biology of animals from her very rapid dissections. So, you know, if you have little kids around, keep them with you, show them these things. You never know, you might be raising the next awesome bio teacher. Okay. Finally, I want to show you all the kidneys of the fish. So you see this red stripe running along the spine of the fish? This red stripe running along the spine of the fish, that's the kidney. Remember, this is an animal that does not have to worry too much about preserving water. So if you were thinking about the kidney of a kangaroo or a camel or a human, they are all about surviving in terrestrial conditions. So they need to have kidneys that can recover as much of the water from their diet and from their drinking as possible. But a fish now has all the water in the world it needs, and it's not too concerned about recovering water, it's more concerned about recovering salts. So the kidneys are not very distinct structure, they're diffuse structures that lie against the spine. Right? So just to emphasize again, the viscera of the fish is just this little area here. Right? This is where all of the digestion, the osmoregulation, the reproduction, everything happens in this fish. Respiration up here, digestion down here. The rest of this fish, all of this here, and if you think about it, this is what we actually eat in the fish. This is about locomotion, about moving, about finding food and evading predators. Right? So that is our dissection of the fish.